Hey class, now let's learn how to name haloalkanes, nitroalkanes, and ether. So I would say if you are good at naming complicated alkanes by now, this will be really easy for you because all you need to change is the type of substituents. So when we have halogens and nitro groups on there, we can treat them as individual substituents, and they'll be named like fluoro, chloro, bromo, and iodo for halogens, and for nitro group, it'll be just nitro. So we can take a look at some examples. Like the first one, when you have an alkyl group earlier, what do? We'll just find the backbone. So in this case, it's still 3 carbon backbone, and we'll just number them 1, 2, 3, and then this chloro will be treated as a substituent. So this one, how do we name it? It'll be just 2-chloropropane, right? Now when I have two substituents, how should I name them? So the one on the left would be methyl, and then the one on the right would be bromo. So we still arrange them alphabetically. So how do I name this one? So 2-bromo, 2-methyl pentane. Alright, you can pause the video and try to see if you can name the other two. Okay, I'm just gonna finish writing the answers here. It's gonna be (5-bromo), heptane, and then this one would be just like 1, 2, all right, you can check the answer and see if you got the same thing. Now you can try these 3 problems by pausing the video. Okay, the last one would be which one do I number 3 and 4? So 1 is fixed. Again, this we can do alphabetic order. So bromo comes first, then iodo. So I could do this as 3, this as 4. So it's going to be 1, 3, di-bromo, 1, 4, di-iodo, cyclopentane. All right, now let's look at another type of problem. So when the names are given to you, and you're asked to draw the structures, I would say most of the time this type of problem is a lot easier than giving you the structure and ask you to write the names. So all we need to do is identify the backbone, starting off from the backbone, and then now you can number it however you want. You can put 2-chloro on the first position and nitro on the second position. you can pause the video and try out the second one. Okay, so you just need to find the backbone and then 111, 111, bromo, 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 2 bromo, propane. That's it. Alright, trivial names. Trivial name or common name. So far we've been naming halogens as a substituent, like identify the alkane part or alkyl part as the parent, and then halogens are named as substituents. So it's haloalkane, chloroethane. So for simple alkyl groups, we can also name the alkane part as alkyl group, and then so your halogen will be your parent. So in this case, we'll change it to halide. Like this one, we can also call it ethyl chloride. Okay, so let's see this structure. What is the systematic name for this structure on the left? So it's a 1 carbon, it's methane, chlorine as a substituent, chloro. So it's going to be dichloro. Oops. So dichloro. It's going to be dichloromethane. Dichloromethane, for short, we'll also call it DCM. So DCM. This is a very commonly used organic solvents in the lab. So common name wise, we can also call it, can name this as a substituent, and then halide, chloride. So CH2, we call it a methylene group. So we can call it methylene. Chloride. So we can call it methylene chloride. What about the one to the right? Systematic name would be trichloromethane, and there's another common name that are different from this naming method. We just call it chloroform. So this one will also put you to sleep. These are halogenated solvents, so this one is also a very commonly used solvent in the lab. They're relatively toxic, so you want to be very careful when you use this type of solvent, because in general halogens are very toxic. Okay. Alright, ethers. So I mentioned the most commonly used ether is probably diethyl ether. So it's a very commonly used solvent in a lab. It was also originally used for anesthesia purpose, so it can actually make you happy. Systematic name for ethers. So we say ethers are like 2 alkyl groups connected by an oxygen. So what we can do is we can look at the alkyl groups individually, see which is bigger or larger, and then we can chop it from there and treat the bigger alkyl groups as parent. So this one has to be bigger. And then the other parts, we can call it alkoxy. So an example here is in this ether, the alkyl groups to the right is bigger, so it's treated as parent pentane, and on the left side it was like ethyl, so we change it to ethoxy. Okay, so look at an example. like this one, A here, which side of the alkyl group is bigger? It's left. So the parent name is called propane. So how about the substituent name? Ethoxy. So we can call it ethoxypropane. It's understood that it'll be at position 1 when we don't indicate the location there. Or if you want, you can also do 1-ethoxypropane. It doesn't hurt. Alright, you guys want to pause the video and try these two? Okay, so for B, definitely this will be a substituent, this will be a substituent. So how should I assign numbers? So this will start from E, this start from N, and I would probably do alphabetically because it's 1, 3 either way. So I'll do 1 ethoxy, 3 nitro, cyclohexane. What about this one? Which side is bigger? So cyclopentane is bigger, so this will be your substituent. So it's going to be cyclopropoxy, cyclopentane. I hope that's fairly straightforward. Okay, common name for ether. So because ether have 2 different alkyl groups, right? We can also name the 2 alkyl groups individually and arrange them in alphabetic order and add ether in the end. Add ether in the end. So this is usually for simple alkyl groups. Like for this one, we could call it, arrange alphabetically, would start off from ethyl, methyl, ether. We'll call it ethyl, methyl, ether. And then this one, we don't count terts, so we could do T-butyl, methyl, ether. And then this one would be ethyl, ethyl, ether, or that's what we call diethyl ether. Okay, so coming back to the problem above, can we name this with a common name? It'll be ethyl propyl ether. This one is going to be a little hard. This one is hard. This is when systematic name is needed because it's so hard to name this part. And then this one could be cyclopentocyclopropyl ether. Alright, I guess that concludes the whole chapter. I hope you enjoyed it. And pretty much what you need to know for this chapter will be in these 3 videos. And the problems in the exams will be very similar to the problems in this tutorial or in your homework. Okay.